Okay, this is a Day 19 Solution video. It's the Chapter 6 review. I got a few requests. I've got one for 1B, which is the sine of 90. Come on. Sine of 90 minus theta. I'm just going to go minus x. It's just easier with this pen. All over cosine of theta or cosine of x. All right, basically just says simplify. So there's nothing to move towards. You're just going to continue to work. Well, obviously this is a difference. So the difference is going to be the sine of the first times the cosine of the second minus the sine of the second times the cosine of the first. And that's all over cosine of theta. Or x rather. Now, sine of 90. Well, right here is 90. That's 0, 1. So the sine of 90 is 1. The cosine of 90 is 0. 1 times the cosine is the cosine of x minus 0 all over the cosine of x. So this simplifies to 1. Okay, number 2, of course, verifying the identities is nobody's favorite. Well, basically, I've got two fractions here. I'm going to go ahead and add those together by taking a common denominator. So the first one needs to be multiplied by the sine of, the sine of x over the sine of x. I don't know what happened to the top of this. All right, so the sine of x times the sine of x gives me the sine squared of x over the common denominator here, the sine of x times 1 minus the cosine of x. Just leave it like that. Plus now this guy needs to be multiplied by 1 minus the cosine of x over 1 minus the cosine of x. So denominator, of course, is going to be the same. In the top, I'm multiplying 1 minus cosine of x times 1 minus cosine of x. So I'm going to be foiling first terms, 1 times 1, minus the cosine of x for my inners, minus the cosine of x for my outers, minus 2 times the cosine of x. Not sure what happened up here, sorry about that. And the last term's negative cosine x times negative cosine of x is plus the cosine squared of x. All right, I'm going to put all this together. I'm going to take the first term and the second term because addition I can put in any order. Sine squared of x plus cosine squared of x plus 1 minus 2 cosine x all over, let's just go LCD for now, sine x times 1 minus cosine x. Sine of x plus sine squared of x plus cosine squared of x is the Pythagorean identity, so it's 1 plus 1 minus 2 cosine x all over my LCD. It's not a 4. Why that looks like a 4. Okay, 1 plus 1, of course, is 2 plus, how about minus 2 cosine x all over my LCD. And I'm going to factor out the common factor of a 2. That leaves 1 minus cosine x all over sine x times 1 minus cosine x. And the 1 minus cosine x's will cancel out, leaving me 2 over sine of x. Well, 1 over the sine of x is the secant, so 2 times the, did I say secant? Cosecant of x, and that's what we have on the right hand side. So there we have it. Okay, 2b is the cosine to the fourth of x minus the sine of the fourth of x, and that's going to equal this guy over here on the left hand side, or right hand side. Immediately I see two terms of difference of two squares, so I'm going to look at this and factor it, and that's going to give me the cosine squared of x plus sine squared of x times the cosine squared of x minus sine squared of x. We all know this is 1. So we're down to the cosine squared of x minus the sine squared of x. Well, let's see what we want. We want 2 sine squared x. Okay, well, I've got one of them, so I'm not messing with that. So I've got to do something with this. Use the Pythagorean identity, cosine squared x plus sine squared x equals 1. Therefore, cosine squared x is equal to 1 minus sine squared x. So I'm going to replace this with 1 minus sine squared x minus sine squared x. Oh, well, look at that. That's 1 minus 2 sine squared x. Okay, in 2c, on the right-hand side, I'm not going to work with the right-hand side, but I'm going to note that the sine of 2x, that's a double angle. So the double angle identity for the sine of 2x is 2 sine x cosine x. So if I get this on my left-hand side, then my next step can say, okay, it's sine of 2x. When I look at this, I see 2 values in the denominator. I could certainly, it just jumps out and says Pythagorean identity. And I tan for a second, so 1 plus the tangent squared of x is equal to the secant squared of x. Well, I'm going to go ahead and change everything to sines and cosines. So in the numerator, I've got 2 sine x over cosine x divided by secant squared of x. Well, that's 1 over the cosine squared of x. So now let's bring this up and multiply by the reciprocal. So that's going to give me the cosine squared x over 1. This cosine eliminates one of these cosines. So it looks like, if I can just continue to come down the left-hand side, I'm down to exactly what I need to be, 2 sine x cosine x. So that changes into the sine of 2x. Okay, number 3 tells me that the sine of alpha is equal to 5 over 13. It also tells me it's in the first quadrant. So I draw my triangle in the first quadrant, use the Pythagorean theorem to find the missing side, which is 12. It also tells me the tangent of beta is equal to 8 over 15, and that the beta lies in the third quadrant. In the third quadrant, the tangent is positive. However, the opposite and the adjacent side are both negative. And using the Pythagorean theorem again, I find the hypotenuse or the radius to be 7. I'm going to do A and let you do B and C. They're all the same. They're just basic identities. You just have to have your identity down. The cosine of alpha plus beta is going to equal the cosine of alpha times the cosine of beta minus the sine of alpha times the sine cosine of alpha. I got that messed up. See, it's not that easy. So the cosine of alpha plus beta is going to equal the cosine of alpha times the sine of beta minus the sine of alpha cosine of beta. Sorry about that. And now it's just going to find in the numbers and plop them in there. So the cosine of alpha is going to be 12 over 13 times the sine of beta. Well, over here is beta. So the sine of beta is going to be negative 15 over 17. Subtract from that now the sine of alpha. All right, we're back over here. The sine of alpha is 5 over 13 times the cosine of beta. And over here, beta, now we're going to do negative 8 over 17. 13, 17, both prime, so nothing's going to cancel here. So this is going to be a negative 180 over 221. Now, negative times a negative is going to be plus 40 over 221. So that's going to be negative 140 over 221. And I don't believe that reduces. So you're going to do B and C the same exact way. I'll post those up on Google Classroom so you can check the answers. If you need any more, just ask. I'm going to go ahead and do 4, 5, and 6. That's the most recent stuff we've been working on. Okay, 4 is solving a trigonometric equation. 3 tangent squared of x is equal to 0. And we're solving it for the principal values. The principal values for the tangent, which is what we got here, of x, and the sine of x, I'll just bring them together here, is going to be from positive pi over 2 down to negative pi over 2. So solving this for x, we're going to divide both sides by 3, giving me the tangent of x is equal to 0. And if I take the square root of both sides, I get the tangent of x is equal to 0, plus or minus, but plus or minus 0 is 0. So x is equal to the inverse tangent of 0. And where is the tangent 0 between pi over 2 and negative pi over 2? Well, right here is 1, 0, and the tangent is y over x, or the sine over the cosine. So it's going to be at 0 degrees. So x is equal to 0 degrees. That is the only answer for the principal values because it's between negative pi over 2 and positive pi over 2. All right, number 5, we got the cosine of 2x and the sine of x. Well, 2x and x aren't matching variables, so I'm going to use a double angle identity here. I'm going to match this up with 1 minus 2 sine squared of x plus the sine of x is equal to 0. So I've got a quadratic equation. Let's move everything to the opposite side, basically just changing the sign of each one of them here, or multiply both sides by negative 1. Put my quadratic term first, 2 sine squared of x minus sine of x minus 1 is equal to 0. Now we're going to have to factor this. Factor is pretty easy because 2 is prime. This has to be the sine of x. That means 2 sine of x has to go here. 1 has to be 1 and 1. 1's plus, 1's minus. I need a negative sine x. So there's my minus 2 sine x plus 1 sine x. Sine x minus 1 is equal to 0. Add the 1 over. Sine x equals 1, or x is equal to the inverse sine of 1. And here we're going to do the same thing. So sine x equals negative 1/2. So x is equal to the inverse sine of negative 1/2. Okay, so now we're going to take that information and look at our unit circle, see if we can come up with some answers. Where is the sign positive 1? 0, 1. Positive 1 right here at pi over 2. So this gives me one answer, one solution of x is equal to pi over 2. Where's my sign negative 1/2? The sign is negative in the third quadrant and the fourth quadrant. And the sign is going to be at a reference angle of pi over 6. So those two answers are going to be 1 more than 6 pi over 6, or 7 pi over 6 for the third quadrant one, and 1 minus 12 pi over 6, or 11 pi over 6. And those would be your 3 solutions for that equation. Okay, number 6, we're going to be solving for the most general solutions possible, and I'm going to factor out a cosine of x here, giving me 2 cosine x minus 1. Cosine x equals 0, so x is equal to the inverse cosine of 0. Skipping some steps there. This is going to give me 2 cosine x minus 1 equals 0, or cosine x equals 1/2, positive 1/2. So x is equal to the inverse cosine of positive 1/2. Again, we just go right over to our unit circle and figure out these things. Where is the cosine 0? Well, we've got right here at pi over 2 and down here at 3 pi over 2. Right? They make a straight line. So in this case, I only have to add pi, because from here, if I add pi, it gives me here. Add another pi, it gives me right back to here. All right, so x is equal to 0. No, I only need one of these, not 0. That's what the sine equals, or cosine equals. We need pi over 2 plus pi n, and that will give me all of those solutions. All right, cosine is positive over here in the first quadrant and also in the fourth quadrant. Reference angle for 1/2 being cosine is going to be pi over 3. So these don't make a straight line, so I have to write each one of these answer solutions down and then add 2 pi over n to get all the others. So obviously in the first quadrant, x is equal to pi over 3 plus 2 pi n. And in the fourth quadrant, it's going to be 1 less than 2 pi, or 5 pi over 3. And I have to add 2 pi n to that also to give me my general solutions to come around for my next one. All right, that should do it. Any other questions, please feel free, and I'll be happy to make